All right, these are some additional notes to add to your spiral notebook for section 9.4. 9.4 is talking about some built-in functions in Excel that you can use. Um, so the five that we're going to talk about, one of them is rate. And to calculate the rate, this is called the periodic rate. So remember, the periodic rate is not the same thing as the annual percentage rate. The periodic rate is the amount of interest that you're paying per period. So it could be per month, it could be per quarter, per biannual. So monthly would be 12 times, biannual would be twice a year, quarterly would be 4 times a year. So the rate, the NPER is the number of periods or how many periods you plan on paying on the loan. The payment, how much your monthly payments are going to be or your quarterly payment. The previous value, which is the amount that you started with, and the future value, which is what you're going to end with. NPER is another function. That's the number of periods for the entire loan. So let's say that you knew what the rate was, you knew how much we wanted to pay, you knew what you were going to borrow and the future value, but you didn't know how many times you're going to have to make this payment. That would tell you how many payments you're going to have to make if you want to stick in a certain payment zone. The payment calculation is the rate. Again, we'll talk about that in a second. The number of periods, how many payments you're going to make, the previous value and the future value. The previous value is the value you're starting with, or the present value is what you're starting with. PV is the present value. That's how much you're going to start with. So if you have a rate and you have a number of payments that you want to make and how many payments you want to make, and you have a future goal in mind, what would you have to start with? How much money would you have to put in the bank? Future value, you have a rate, you have a number of periods or number of payments, what the payment's going to be, and the present value. And so in these cases, in all four of these last ones, the rate is always going to end up being the periodic rate. So you're either going to multiply by 12, divide by 12, or something with these problems depending on what we have. So in all these examples, I have spreadsheets to go along with them, but we're going to talk about the functions first. So in this one, you deposit $450 a month into a mutual fund, which has averaged 10% annual rate of return. What's going to be the value of this investment after 30 years? So we're looking for future value. So we need the rate. So in this case, the rate is 10%. The number of payments. So for 30 years, at a monthly payment, it's going to be 30 times 12. Payment, which is $450. Now the negative is because you're giving money to the bank. It's coming out of your funds and going to the bank. And the zero is the future value. The present value, which means you're starting off at zero. And when I put all of this into my Excel spreadsheet, I end up with $1,017,219.57. Okay? Here's another example. I'm going to borrow $5,000. The interest is 4.5% for 5 years. What's the monthly payment? So I'm going to use the PMT function. So the PMT function requires the rate, the number of periods, the present value, and the future value, which is optional. So the rate is 4.5%. Since this is a monthly payment, I'm going to divide by 12. The number of periods is 5 years times 12 because it's 12 payments per year. The amount for the bank is $5,000, so that's your present value. And then your future value is going to be zero because you're expecting to pay it back and end up with a zero balance. So when you put all this into Excel, you get 9322. Okay? So our next one, this time you're going to borrow $5,000 for 5 years. Your monthly payment's $100.33, and you want to know what interest rate are you going to get if you have these terms. So this time for rate, you've got the periods, which is 5 times 12 because it's monthly payments, the amount of payment, which is $100.33. The amount in the bank is $5,000, and your future value is zero. So when you put all of this in, you've got to remember that rate is going to be the periodic rate, not the annual percentage rate. So to make it the annual percentage rate, we're going to multiply by 12 because it's monthly payments, and we end up with 7.56%. Okay, number three, you have a loan for 5 years. The interest rate is 8%. Monthly payment is $93.22. How much was the loan amount? So we want present value. So the rate is 8%. Monthly payments, so it's divided by 12. 5 times 12 because it's 5 years, 12 payments a year. The payment is $93.22, so negative $93.22, and I end up with the present value is $4,597.46. The next one, I have a loan for $5,000. The rate is 5.1%. I have a monthly payment of $100. How many payments do I have to make? That's called the number of payments or the number of periods. So it's the rate, 5.1%, divided by 12 because it's monthly payments. 100 is the amount of your monthly payment that you're making every month. And $5,000 is how much you borrowed from the bank. So when I put all of that in my calculator or my Excel spreadsheet, I get 56.39, which means I have to make about 57 payments of $100 to pay off this loan. The next one, I invested $5,000 at a rate of 5.1% for 5 years, compounded monthly. How much money do I make at the end of the 5 years? So this is called future value because I want to know how much money I have in the bank. So 5.1% is my rate, divided by 12 because it's compounded monthly. 5 times 12 because it's 5 years monthly. The present value is 0 because I don't have any money in the account to start with, and $5,000 is, I'm sorry, there's 0 monthly payment is what I meant to say, and then the $5,000 is how much I started in with my investment. So I end up with $6,448.82 in my account at the end of 5 years. Now number 6, I changed it slightly. So number 6, it says, what if I compounded it quarterly instead of monthly? So what changes about that? Well, remember we talked about the rate is the periodic rate. So you're going to take the rate, 5.1%, and you're going to divide by 4 because it's compounded quarterly. And you're going to take the number of years, which is 5, and multiply it by 4 because it's compounded quarterly. There's still no monthly payments and it's still $5,000 invested. So at the end of 5 years compounded quarterly, which means 4 times a year instead of 12 times a year, I would have $6,441.92 in my account. So then what I did is I took all of this information, I put it into my spreadsheet. And so in my spreadsheet, you'll notice here's the first problem. So I had 10% interest, the years is 30. The rate, this is our periodic rate. Notice what I did is I took the 10% divided by 12. Notice I also named it so that I can use it a little bit more effectively. The number of periods is the 30 years times 12. This is my monthly payment, which I also named payment in my name box. And so in my future value box, I put exactly what I did in the formula on problem number 1, and I ended up with exactly what I have on the paper. So then what I did is I put it into a longer format. So here's what's the math all together. So I had $450 deposited. The interest is $3.75, and I got that by taking the balance plus the deposit and multiplying it by the periodic rate. And then the new balance is all of these values added together. Okay, and then that value comes down here. So I'm going to do this 360 times. Here we go, 360 times, and I just dragged my formula down. And at the end of the 360th time, you'll notice here that the amount in my account is $1,016,769. Now it's a little bit different than what I had up above, and I think it's because of round off errors or something like that. but it's basically giving us the same value that we have up here, which is $1,017,219.57. Okay, so then on this next sheet, what I did is I took each of the examples that you see. Now the part that's in yellow is what I'm doing the actual calculating for. So here's the first example that I had on paper. I had $5,000, 4.5%, 5 years, compounded monthly. That means there's 60 periods because 12 times 5 is 60. And here you'll notice my formula for payment that I had here. So the only difference, oh, this one's the same. So there's my formula for payment. This is example 2. I had $5,000, 5 years, monthly, but I'm making $100.33 monthly payment. So I wanted to know what would be my interest rate at the end of that period of time. So the interest rate for this loan is 7.56. And if you look at my formula, here's my formula. So on the formula, you'll notice that on the paper I had a comma 0 at the end here. And if I put that 0 at the end, it doesn't have any effect on the problem at all. So remember, the things that are at the end that are in brackets are optional. So if I put that 0 in there, or if I take the 0 out, it doesn't have any effect on the problem. All right, the next problem, it's 8% interest, 5 years, 60 periods, and my monthly payment is $93.22, and I wanted to know how much did I borrow. So that's present value, and that looks exactly like I did on my formula sheet. On this one, I did $5,000, 5.1%, $100 monthly payment. I want to know how many periods. So on this one, it looks just like my formula sheet again. So I'm using cell referencing here instead of the actual values, but I could change these if I wanted to. It just didn't give me as much flexibility to show you things on the spreadsheet. Problem F is I gave you 5,000. This is example 5, I'm sorry. 5.1%, 5 years, compounded monthly, and this was the one where I'm sending money to the bank. I'm saving up money. So you'll notice here what I have is the rate, which is 5.1%, divided by 12 because it's monthly payments. The F5 is 5 times 12, which is 60. And then I have 0 payments, and then I have the negative $5,000, and I got 6,448. Now on this one, notice what I changed. The months is 4 because it's actually not months, it's how many periods I'm making, and it's quarterly, so it's 4 times a year. So that means the number of total periods over a 5-year period of time is 20. So when I put this into my formula, notice I divided the rate by 4 instead of dividing it by 12, and I ended up with 6,441. I hope this helps.